mean, like when they launch it, you don't
They get
the
sunblock factor 100 and then just smear it over the rocket before launch.
No. I mean, like launching it from the ground, like into space.
Yeah.
You don't launch it away from the sun.
No, there's no need to.
It doesn't matter. You know how far away the sun is.
Yeah.
Like the heat of the sun.
No, it's okay. It's okay. It's actually cooler up the top because the ozone layer traps heat. So if anything, it's less heat.
But when they get into space, there is no heat.
No, there'll still be heat from the sun, but it actually will be less than on Earth because we're feeling heat that's trapped. Yes. Right. Now, we're having a look at series. No, not quite yet. Just looking at series here. Can we see? Okay. So I have to teach you a little bit of notation. I wonder if anybody has seen this notation before. Yes, it's on the calculator and we'll be using that. Does anyone know what it means? Sum. Yeah. It's a sigma. So, if I write n equals 1 to 5, n squared, what that means is I start at 1 and square it, then 2, then 3, then 4, and then we stop at 5. Yeah? Now this lesson you'll need your calculator, so why don't you calculate that for me? What is it? 55. Okay. Now, what about something like this? If I said n is 5 to 7, 1 over n. What would be the first one here?
1 over 5.
1 over 5.
2 over 5.
No.
1 over 6.
Yeah? Okay, what's that, please?
It's 107 over 210. 107
Yeah?
over 210.
Like this. Yeah? Okay. You don't have to use the letter n, you can use any letter, so like I could say m equals. No, I'll show you that in a minute. 0 to 10. Minus 1 power n. Calculate that for me. Yeah. Now there's a quick way to do this one, okay? So what's the first one going to be? Minus 1 power 0, which is 1. And then the next one, minus 1 power 1. And then the next one, minus 1 squared. So do you see what's going to happen? They'll cancel. They'll all cancel if there's an even number. But if there's an odd number, they won't all cancel, will they? So is there an even or an odd number? No. Odd. How many are there in total? 11. So the first two cancel. The next two cancel. They all cancel, don't they? Except for the last one. Okay. Now, before we continue, I want to show you. Your calculator has this function built in. You've used this before, have you, on the calculator? So let me show you. Using the calculator, for example, like for this one. It's just loading. There we go. Now, can you see here on my calculator, if I press shift, I have this sum button here. So, well, for me, it's above the log. 0 to 10. Yeah, I'm doing this one. Minus 1 power. And now the calculator uses x. So I press alpha x. That's like my n. And I get 1. Yeah. Do you have this on your calculator? Yeah, it's right there. Isn't it? Yeah, there it is, right there.
Yeah.
Yeah.
Ready.
Oh, you did. You didn't put in the X.
You put in the X. I've done that.
You got it? Do most no, yours doesn't. No. Yours, Rahman? Yeah.
So how can I put the number on the upstairs?
Just press O.
Oh.
Okay. But what's nice is you can go up to large values like 100. You'll have to wait a while because it adds it all up from 1 to 100 there. So I'll give you a couple to practice on the calculator now. Can I scroll down? Yeah. So you can use the calculator. I want you to calculate these 3 for me. 0 to 10, 1 over n factorial. 0 to 50, 1 over n factorial. And then 0 to 100, 1 over n factorial. Get the second one? And the third one? Now, it's not exactly the same each time, is it? It's slightly different, yeah. But it seems quite clear that if I was to continue this process of adding 1 over n factorial infinitely, then I don't get infinity as the answer. I think I will get 2.718. So this is an example of a series which is convergent series. Now, not all series are convergent. For example, if I go back to the one earlier, do you remember this one here with the n squared? If I was to replace this with infinity and I keep going, converge or diverge? Diverge, yeah. I mean, diverges rapidly, doesn't it? Because you have 6 squared, 7 squared, 8 squared. You keep adding these. So, using 10, 50, and 100 again, I want you to tell me, do you think this one here, 1 to infinity, 1 over n, will converge or diverge? Check. No, Bello. Listen, I said doing what you did here. Check. Check with 10, 50, and 100. Don't put in 1,000 because the calculator will freeze. Now you know. Is it frozen?
Yep.
Yeah, you're going to have to wait 3 or 4 minutes now.
Yeah, it's better.
Yeah, that's
Yeah.
They look for it.
Oh, you have it?
Yeah.
Okay, hang on. Right, so you went up to 1,000, and what did you get?
7.485.
And then did somebody go to 100?
Yeah.
What did you get for 100?
5.1.
Okay. Okay. Right, so what happens if you go all the way to infinity? Converge or diverge? What do you think? Diverge, yeah. Okay. Now, let's do another one. Again, do you think this series will converge or diverge? So what you can do, I'd like you to check for 10, 100, and Rodman, if you got a powerful calculator, can you do 1,000? Try, okay.
I don't know how to calculate that.
Calculate what?
Because I know how to, because I don't know how to control our value.
Mine should be error when I put
Show me. Show me what you typed in.
100 is 1.6.
Wait, which 100 is?
1.634.
And 10?
The 1,001 is 1.6.
10 is 1.54.
Okay, and the 1,000?
1.6439.
Okay, 1.6439, okay. So what do we think? Is this a convergent or divergent? It's looking like it's convergent, isn't it?
Yeah.
Yeah. Now, how can you actually calculate this? Can we do this on the calculator? No, because the calculator will calculate 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared plus 1 over 4 squared, and when will it stop? Never. So how long will you have to wait to get an answer?
Forever.
Yeah, eternity. Yeah. Now, we can't really do that in a 50-minute class. We don't have the time to do it. So, in order to do this, we'll need something that can calculate up to infinity, right? Which is difficult because you need infinite power, correct? Right, so just give me 1 second. All right, got the answer here. It will be pi squared over 6. You can type in pi squared over 6 and you can see. It's working. You just have to wait.
I don't know how to do that.
Show me what you typed in.
Because I
Show me what you typed in. Put in the numbers.
because
Put in the numbers and then show me.
You don't know.
Calm down now.
Ah,
Just
you can't go to 100. It's too big for it. You might want to try 10. There you go. 10's okay. Okay.
Why is that?
Why?
Yeah.
I just counted up to infinity.
Wow.
Can you not count up to infinity?
You can't buy it.
Yeah. Well, I think it's obvious, isn't it? Right, the next one.
teacher, I don't know how to do it.
What's wrong? No. What number goes down here?
Because I
No. No, but that's not what I wrote. I wrote 1 to 10.
So how can I
You have 10 to 0.
Yeah.
No. Son, look at what I wrote. I wrote this.
Yeah.
I have 1 at the bottom and 100 on the top.
Okay.
Yeah, you need to type in what I wrote.
I tried.
Okay. Continue. So the next one, 1 to infinity, 1 over n factorial. Just a sec, hang on. Yeah, okay.
thank you over 6.
What is it? No, e.
Yeah.
Yeah.
So you
Oh,
have
yeah.
to solve for 8.
Yeah, I can answer.
Good. Okay. What?
Just say that you solve for 8.
Kept saying what? Pass that up without clearing it, please. Pass that up without clearing it, please. Thank you. No, what are you doing?
Exactly, I told
What are you doing? You can't. No, this
And
doesn't make any sense.
And also solve, like, solve, like,
Yeah, but you don't have infinity. You have 10.
oh,
Okay. Exactly. Exactly. I'm sorry. Does your calculator have infinite memory and infinite processing power? No. Okay. Now the next one here, if you were to do this one, 1 to infinity, 1 over n, that total is infinity. Okay? So my point I'm making is, it's not clear just looking at the series formula whether it converges or diverges, right? Because these all look very similar, don't they?
Yeah.
Yeah.
But they're very different in the answers. This one gives me a pi, this one gives me an e, this one gives me infinity. No, don't worry about calculating these today, because for today's lesson we won't be calculating up to infinity. We'll be calculating up to a smaller number like 10. Okay, so we don't have to worry about that one. Let me just give you another one to practice. Let's see if you can handle this one. Without using your calculator, without using the calculator, 1 to 10, 2. No calculator. Put the calculator down. You don't need it for this one.
22.
What's it going to be? What's it? 20, yeah. Because it'll be 2 plus 2 plus 2 plus 2 plus 2. How many times? 10. So this will add up to 20 then. Yeah, 2 times 10. Yeah. Yeah. Yes?
Who came up with this stuff? Why are we not moving forward now? Why is it just...
Sorry, I can't understand sweet in mouth language. Could you just finish that and then ask me? Right, I'll give you another one. You can use the calculator for this one. Okay, we'll go... yeah, okay, we'll just go 1 to 100 n. Yes.
Why is it just 2? I thought it's like 50-50.
When n is 1, what's the value of 2? Yeah, 5050 is the next one. When n is 1, what's the value of 2? What value does the number 2 have when n is 1?
I'm not getting it.
The number 2.
Yeah.
How big is it when n is 1?
1.
Correct. When n is 2, how big is the number 2?
4.
How could the number 2 equal the number 4?
I'm not getting that the way like...
I'm also not.
But
I'm not understanding like...
Right, listen carefully. Listen carefully. The number 2,
Yeah.
what's its value?
2.
Good. Okay. What's the value of the number 2 if it's raining outside?
2.
Okay, so far so good. Okay, if it's sunny outside, if alpha is equal to 6, what's the value of number 2? Still 2. If n is equal to 1, what's the value of 2? And if n is equal to 2, what's its value? 2. And if n is equal to 3, still 2. 2 plus 2 plus 2 plus 2 plus 2 plus 2, 10 times.
So how did you now do it like when it was before? Because like in the other examples, I'm now seeing like 1 square, 2 square, 3 square, 4 square.
Like this one here. What's the value of n when n is 1? What is the value of n when n is equal to 1? 1.
Yeah, 1.
Okay. What is the value of n when n is equal to 2? 2. Plus 3, all the way up to 100. N equals 1, then n equals 2, then n equals 3. Yeah. Yeah? You know this. This is just a little bit like, you know the way you have fx equals, say, x squared, okay? When x is 1, what do you get? 1. When x is 2, what do you get?
2.
4. etc. Just with n, okay? Now, suppose fx is equal to 2. What does f1 equal? 2. What does f2 equal? 2. What does f3 equal? 2. Why? Because fx equals 2. Yes? Okay. Right?
Yeah.
Yeah, okay, let me give you a couple more. Okay, try this one. You can use your calculator if you like. N equals 1 to 10, 1 plus 2n. 120, is it?
Yeah.
One point.
120.
Thank you.
Is it the special calculator? Yeah, that's special.
1 to 100. Yeah, see what happens if you try n cubed. I think it should be quite small. What is it?
1.20.
Okay, one.
You got that?
Yeah, one.
Yeah, you got that?
Me?
Yes.
My calculator doesn't work.
What calculator you got? Okay. Right, let me give you one more here. Let's see. Let's see. Okay, let's try this one. Minus 10 to 10. 1 over n plus 21. Yeah. 1.09? What?
Like, even typing it down is hard, so I don't see how like, why?
The reason I did this one is to show you that n could be positive or negative. I mean, it's usually positive, but I mean, it could be negative. So, if you put the 10 in the wrong spot, it should be in the box. Look at the calculator. The box needs to have the 10 inside of it, not in front of it. Now, look. Look. Where's it gone? It's cleared. Type it in again.
God, okay.
Okay.
The minus 10 is meant to be in the box, right?
No, up the top, you didn't put the 10 in the box.
Yeah.
No, you didn't.
That, like I made.
No, it's like this. Look, Bello. There's a box here up the top, okay? You have to type the 10 in the box. You typed it outside the box. Yeah, you got that?
Yeah.
Okay, so look, even if you don't have a fancy calculator, you can still use your calculator, or you just have to do it one by one. Okay? Because the biggest, at most there's 10 numbers to add together, but I don't even think I have 10 in any of them. I think the biggest is maybe just 5 to add together. So, even if you don't have a fancy calculator, you can do it. Oh, lastly, just to say, if you had something like this, what does the tree on the outside do? It multiplies the sum, the answer by tree.
Yeah.
Yeah. But by the way, if you were to multiply the tree inside, like this, would you get the same answer or a different answer? What do you think? Same or different here? Equal, not equal?
Same answer.
It'll be the same answer.
Yeah.
It doesn't matter if the tree goes in first or last. Okay?
And in the exam you can just write the final answer.
No, in the exam, they would want you to do something like this. So if you had an exam question, like let's say 1 over n squared, n is 1 to 5. They want to see you write down 1 plus 1 over 2 squared, 1 over 9, 1 over 16, 1 over 25 equals 1.6 or whatever. They want to see the 5 numbers. Okay?
So,
So, what is it? 1?
4.9.
No, I don't have the tree in this one. Okay, so if the tree was in here, you could do something like that, and you get 4.9. Okay?
yeah.
Right. So they're quite easy, yes? Page 38. You got page 38 there? Yeah? Okay, all of them on 38. Oh, yes, and you can use your calculator. Look, guys, all I'm asking you to do is to type numbers in on your calculator. Okay?
Yeah.
That's all. I could train a kindergarten student to do this, okay? Easy lesson. That's correct.
But
All
in exam,
questions.
we're not supposed to type it in.
Yeah, but for today I just want you to practice.